Okay, 2.8. This is going to be a pretty short section. We're going to cover distance formula, midpoint formula, and circles. So we'll start with the distance formula. So what we're doing here is we're finding the distance between any two given points. That's really all we're doing. So basically, we're going to look at this sort of situation. Let's say we got a point here, and we got a point here. Let's call this x1, and we'll call this x2, and we'll call this y1, and we'll call this y2. And we'll connect those 2 points and call that's a line segment as opposed to a line, right? A line is when we have arrows on the end and it's going out in either direction to infinity. This is called a line segment. It's a segment of a line. We are interested in what is the distance from one point to another. So if we do it like this, we have 2 points, right? This point is x1, y1 here, and this point is x2, y2. And we want the distance. We want this, we'll call it d for distance between those 2 points. So notice if I draw a horizontal line out this way and a vertical line down this way, I form a nice right triangle. And hopefully we all remember our great friend Pythagoras, who says that in any right triangle, right, if we have any right triangle, and we call this C, A, and B, then we know that the hypotenuse, the side opposite the right angle, squared, is the sum of the squares of the other 2 sides. Now Pythagoras is mostly remembered for this, but a very interesting story about Pythagoras. When Pythagoras was around, if you were one of his pupils, if you tried to study this kind of stuff, this kind of simple math that is available to you now every day, if you were caught studying with Pythagoras, you could be put to death. That is a true thing. Studying this material at one time, 2,000 years ago or so, could get you killed. So appreciate what we're learning here today, because now you're not going to die because of this knowledge. Right? But anyway, Pythagoras, he's most remembered for this Pythagorean theorem. And that's what we're using here to find this. We're calling this the hypotenuse, the C value here. And now we know these distances here, the distance between this and this is just the difference between the x2 and the x1. So that's x2 minus x1, this distance here. And this distance here is the difference between the y's. And now we can use this formula to come up with that d value. So d squared is the sum of the squares of the other 2 sides. Okay, now we're not solving for d squared, we want d, so we're going to take the square root of both sides. And since we're talking about a distance, we're just going to take the positive square root. So we're going to say d is the positive square root of the sum of the difference in the x's squared and the difference in the y squared. And that is the distance formula. All right, so again, you don't need to memorize these formulas, you just need to be able to use them when given a situation. So let's look at any 2 points. Let's see if I got any good ones picked out here. The numbers aren't too messy. We can choose any 2 points we want, really. We're just going to maybe avoid some fractions. Let's see here. All right, so I'll just pick a couple points. Maybe we'll get some fractions. No problem there. All right, so let's say we have, I don't know, this situation here. We'll call this point 1, 6. And we'll call this point 5, 3. All right, and we want to know the distance between those 2 points. All right, so all we're going to do And here again, it doesn't matter which point you use to be your x1, y1, and which point to be your x2, y2. Just be consistent, again, once you make that choice. So I'll call this one x1, y1, and this one x2, y2. And if I want the distance between those 2 points, I'm going to plug those values into my formula that we just derived. And again, it doesn't matter if you put the difference in the x's here or here, since we're adding. I generally just put the x's first. So the difference in the x's squared, right, x2 minus x1 squared, plus the difference in the y's using the same direction, 3 minus 6 squared. And then you're just going to simplify as much as you can, see if you get a nice number. So here we're going to get 4 squared plus negative 3 squared. Oh, look at what a nice number I got there, right? I just made these numbers up, I want you to know. Look at that. 16 and 9, we get a nice, even, whole number. Amazing. Absolutely amazing. All right, so that's how we find the distance between 2 points. Any 2 points. Again, just be consistent. Once you label one as your first point and one as your second point, a common mistake, some people will put, you know, x2 minus x1 here, but then reverse the direction. So just be consistent once you make your choice. Okay, something else about a line that we're interested in is the middle of a line segment. Okay, again, these are line segments, right? As opposed to a line which goes out to infinity. So for a line segment, we're interested in what is the length of that line segment, that's the distance, and the midpoint, which is a pretty straightforward calculation. Midpoint of a line segment. All right, so let's say we're given 2 endpoints of a line. Just like we did over there, again, we'll call it x1, y1, and x2, y2. The midpoint is just very simply, we'll call it M for midpoint. The midpoint is going to be simply the average of the x's, is going to be your x value, and the average of the y's is going to be your y value. It makes sense, right? It's in the middle of the line. So the average of the 2 x values, we take the x values, add them together, divide by 2, add the y values together, divide by 2 to get the midpoint. So if we do the same, use the same line segment over here, we can say the midpoint here is going to be the average of the x's, and then the average of the y's. So we end up with 6 over 2, or 3, and 9 halves. And then you maybe give it an eyeball, and you know, if you came up with negative 3 something, you'd say, oh, wait a minute, that doesn't make sense. But you look at this 3, this is 4.5, that looks right about where it should be. Right? Okay, so distance formula and midpoint. You want to be able to find the distance between any 2 points, and you want to be able to find the middle or the midpoint of any line segment using those procedures. All right, and circles is the last thing in chapter 2. So circles, we're going to deal with this equation for a circle. So equation for circles. All right, let's see if I can remember this. X minus h squared, y minus k squared equals r squared, where hk is the center of the circle, and r is the radius. Okay, so we're talking about a circle where the center is a point hk, and the distance from the center to any point on the edge of the circle is the radius r. All right, so for this section here, we're going to be asked questions about circles in at least a couple of different, at least 2 or 3 different ways. So the first way you'll be asked a question about a circle is you'll be given the center and the radius and asked to come up with this equation. Okay, so this is the main thing we're looking at here. Once we have this, sometimes you'll be given this equation and you'll be asked what is the center and what is the radius. In that case, all you're doing is looking at these numbers. These are going to be numbers when it's an actual circle. And you're taking it to be the center. Just be careful with the signs, right? It's x minus h and y minus k. So if you got something like this, you're going to look at this as x minus a negative 2 and y minus 3. So here your h would be negative 2 and your k would be positive 3. So the center here would be at negative 2, positive 3. So just be careful with the sign because it's always minus the h value. So if it's plus, the h is going to be negative. Same thing here. If it's a plus, the k is going to be negative. In this case, it's positive. So sometimes you'll be given this equation like this and asked to come up with the center and the radius. So in this case, we just found the center. The center is at the point negative 2, 3. And the radius is the square root of this number. And again, we're just looking at the positive since we're talking about distances and measurements. So our radius is 2. Okay, so that's pretty easy, right? When you're given the equation, all you got to do is pick out the h, the k, and the r squared, or the r. Sometimes you'll be given the center and the radius and asked to come up with the equation. So that's another way you'll see this. Asked, it'll say given a center at, say, 0, negative 3, and a radius of 3. And you'll be asked for the equation of the circle. Give, and this is called the standard. I believe it is. Standard, let me make sure I got that right for the book, because there's a standard form and a general form that we're going to look at later. And the one we're looking at there, this one's called the standard forms. All right, so give standard form. So this is hopefully really easy here. Our h is 0, our k is negative 3. So we put that in, 8x minus 0 squared. You don't have to put that 0, but that's what's going on. X minus 0 squared. Now it's y minus a negative 3. So y plus 3 squared, and the radius squared. So you don't really need that 0. So it's x squared plus y plus 3 squared equals 9. And that's the standard form of the equation of a circle whose center is at 0, negative 3, and whose radius is 3. Now, if you have a circle centered at the origin, right, then the center is 0, 0, and let's say this radius is 1. This is kind of the most basic circle. X squared plus y squared equals 1. Right? We call that the unit circle. It has a radius of 1, meaning 1 unit. It's centered at the origin. If you take any trigonometry, you'll see a lot of that circle. All right, so there's another form for a circle called the general form, or general equation for a circle. Let's look at that one. General form of equation for circles. Okay. And this is on page 317. All right, I'm not going to rewrite it here, but we'll do an example of one. Now this is where, remember I told you completing the square was going to come back again. This is one of the cases where that's happening. So if we look at number 54, on page 319, we're given an equation of a circle in general form. And that is, what did I say, number 54, x squared, y squared, 8x, 4y, 16. Okay, this is general form. This is the form on page 317. The question is the same. What is the center and the radius of this circle? So we got to change this to the standard form that we were looking at. And to do that, we're going to use the technique of completing the square, which we discussed when we talked about solving quadratics. So this is in general form. We're now going to gather the terms with x's together and complete the square on the x's. And then we're going to gather the y's together and complete the square on the y's. And that's how we're going to get our standard form. Right? So take this and gather the x's together, x squared plus 8x. And then gather the y's together, y squared 4y, and put the constant on the other side. So negative 16 from both sides, negative 16. All right, so notice what we're trying to do. We're trying to get to this, right? But these aren't squared. I mean, this is a quadratic expression, but we want a binomial squared, right? We need a binomial squared and a binomial squared. So we want to create a perfect square trinomial here and a perfect square trinomial here. And we know how to do that from chapter 3. Right? So for this one, we say the b term is 8, half the b term is 4, and half the b term squared is 16. So that's what we're going to add inside here to create a perfect square trinomial. Now, of course, remember it's an equation, so whatever we do to one side, we have to do to the other side also. Then we do the same thing here. Here the b term is 4, right? The number in front of the variable raised to the first exponent. Half of that is 2, and half of that squared is 4. So that's what we're adding to that binomial to get a perfect square trinomial. So let's come over here and do that. So now we got x squared plus 8x plus 16 plus y squared, 4y, and 4. And then on the other side, we got the negative 16. We added 16 to this side, so we have to add 16 to this side. We added 4 to this side, so we have to add 4 to that side. Okay, so what we've done, if you remember back to chapter 3, we've created a perfect square trinomial, which is now going to factor into a binomial squared here, and over here we're just left with 4. And if we, again, remember our lesson from chapter 3, our only choices for the first term in each one of those is the x and the y, and the number that goes here is always the number that you found to be half the b term over here. So this is a positive 4, and over here a positive 2. So we put a positive 4 here and a positive 2. So we've taken the circle given in general form, we've changed it to a circle in standard form, which is now a lot easier to read off the center and the radius. So again, it's a plus and a plus, so our center is negative 4, negative 2. So we say that, center at negative 4, negative 2, and the radius is the square root of 4, or 2. All right, so that is everything in 2.8.